All right, homework 5, demo. So let's first start with this Monopoly question. This is very similar to what you see on your homework. Question 2 will be pretty similar to what you've seen on your homework as well. So we have a demand curve, and we have a cost function. So for the monopolist, we want to find the profit maximizing price and quantity of recliners, as well as the profit for the firm at this price and quantity. So we're asked here maybe to start with a sketch. So we set up our two axes. And so here we have a downward sloping demand curve that intercept. So when quantity is 0, we have an intercept of A. And when price is 0, we have an intercept of A. And then our cost looks like this. We have a sort of square term. Okay. So the monopoly wants to set MR equal to MC. So this is our MR. And then let's try to find an MC. So MC is equal to the derivative of the cost with respect to Q, which just comes out to be 2Q. So here, that's just linear. That looks like something like this. So we find the firm's optimal choice where MC equals MR. So this is our Q star. And this is our MC and the price. We also want average total cost, or average cost, which is C over Q. Which is just Q. So this looks like, so it's a little flatter than MC, so it looks like this. Okay, so then we have AC here. All right. So this is the graph. We have the demand curve, we have the marginal revenue curve, we have the marginal cost curve, and the average cost curve. So we're asked to label this with PM and QM, so we have M and M. And let's just go ahead and label the profit, which, do this in brown, that's the profit. Okay. So we're asked to actually go ahead and find the profit maximizing price and quantity. So to do this, we just set MR equal to MC. MC is equal to 2Q, and MR, so we have to go ahead and do this. So R is equal to price times quantity. Price is given here, so that's A minus Q, and then we multiply that by quantity. So we have A minus 2Q. So our MC, or MR, is equal to the first derivative of this. And we need Q. Nope, what did I do here? So the first derivative of our M of our revenue curve, so we have AQ minus Q squared, is A minus 2Q. So we set these equal to each other. We have A minus 2Q. So all we're left with here is A is equal to 4Q. So Q is equal to A over 4. So this is our monopolist's quantity. So to find price, all we do is take this and plug it into the demand curve. So we have price is equal to A minus Q, which is A over 4, which comes out to be 3 over 4A. Or maybe to write it with one more step, we have A 4A minus A over 4. So then PM is equal to 3 over 4A. Just like that. Okay. And then we're asked to find the profit. So to do this, we need to find average cost. So average cost is just equal to quantity. So we have A over 4. So our profit equation is just quantity M times PM minus AC, which comes out to be A over 4 times 3A over 4 minus A over 4. Okay? So this is A over 4 times the inside. We have 2A over 4, which is just equal to, so the inside is, write this out fully, A over 2. So our profit is equal to A squared over 8. All right. That's a profit. Okay. So for part B, so we're asked to charge the socially efficient price. So to do this, we have to realize that the marginal cost curve is the supply curve. So this is the supply curve. So the socially efficient price happens when supply equals demand. Let's write demand here. So to do this, to find the socially efficient price, we need that our demand curve, we need to find where demand is equal to marginal cost. So our demand, our inverse demand curve is A minus Q. So A minus Q. And our marginal cost is 2Q. So we have 2Q. So then we can solve for Q. So we have Q, we have 3Q on one side is equal to A. So then Q is equal to A over 3. And that's our quantity, but what we actually want is the price. So all we have to do is take this and plug it into either side of this. And the easier one here is to plug it into the marginal cost curve. So the socially efficient quantity is 2 times Q star, which is A over 3. So P star is equal to 2/3 A. Okay. So we found the socially efficient price. What quantity would they produce at this price? So the first thing to do probably is to label the point representing the socially efficient price and quantity with P star and Q star. So let's just do this graphically. We sort of started off with it. Let's just finish it. Q star and P star. So we found P star, and we've already, without sort of realizing it, we've already found Q star. Okay. So at this price, the monopolist will produce at the socially efficient quantity. All right, so that's nice. So the last part is to find the deadweight loss. So let's go back up and illustrate it in our graph. And maybe we'll use neon green. So we know the socially efficient happens here. We know we're producing here. So our deadweight loss is this area here, deadweight loss. So we want to find that area. And the deadweight loss is just equal to 1/2, because that's a triangle, times height, which is PM minus MC. So this is the markup coming from the market power, times the change in the quantity. So this is Q star minus QM. Okay, so let's copy this. So we have all these numbers. So all we have to do here is plug them in. And the nice thing here, just as a note here, we could use an integral, but because we know all these equations are linear, that the marginal cost curve and the demand curve are linear, then we can just use our equation for a triangle. So that's what we're doing here. Height times base divided by 2. So our price for the monopoly is 3/4a. 1/2 3/4a minus marginal cost, which we need to calculate. I don't believe we've done this yet. So we take our QM and plug it into the demand curve. So we have marginal cost. We plug it into the marginal cost curve. Our marginal cost curve is 2Q. So 2 times QM, which is A/4, which just comes out to be A/2. So that's our marginal cost. 1/2A times Q star, which we found here, we have A/3 minus QM, which we found above, which is A/4. And then we just simplify this. So we have 1/2. We could rewrite this as 2/4. Make this cleaner. 2/4. So that leaves us with 1/4a. And then here, this is a little bit more involved, but let's just put an arrow to it and expand. So we have 1/3, which is 4/12 a, minus 3/12 a. So this just leaves us with 1/12 a. So what we have here is a deadweight loss of a squared times 1/8 times 1/12. Okay. And that's, let's see if I can do this in my head, 80 plus 16 It's 96. Oops. 1 over 96 a squared is our deadweight loss. Okay. So we'll leave this here for this video, and we will follow up with our oligopoly question in the next one.